So here's 5.2, slope of a line segment. Um, each line segment on the grid has endpoints with integer coordinates. So what that means is the endpoints of a line are just literally the points on the end of the line. So like an endpoint would be there and an endpoint would be there. So if it says endpoints, that's all it means, right? Just like it sounds. So, and it says with integer coordinates. So it just means it's not ending at like, x is equal to 3.110 or 3.17 or something like that, right? So it just means it's landing on an integer value. That's going to be helpful for us to figure these things out. So if we look at this table, it says we want to find the rise, the run, and the slope of this thing. The slope of any line is just the rise over the run. And what we mean by the rise over the run is you can make a little triangle out of every one of these things. And the rise is going to be the rise part of it. So it's going to be how big this part is. So this is the rise. And then that leaves this is the run. The part running down the side. That's all it is. So we're just having that number divided by that number. So in this case, if we can count the blocks is going to be the easiest. So I can say the rise of this thing, of CD, I'm doing CD first, sorry, is going to be 3. So 3 up and down, so that's my rise. My run is going to be, it's going to be 1, 2, 3, 4, 5. So simple enough, I would just say the rise of this one, so I'm filling in my chart, would be 3. The run would be 5. So the slope, I would say, for rise over run, that would just be 3 over 5. It would also work to write that as decimal, but this works too, just write it as 3 over 5. Yeah, the only other thing I want to add, a couple things I guess, is so that's positive, and anything that's going to be going up and to the right, we're going to call a positive slope. Anything that is going down, like if you're going down a slide like this, if you were going left to right, going down, so like A, B, we're going to call that a negative slope. So there's going to be a negative number in there. So that's all you really have to know. So let's do A and B. So if we're going to say what is the slope of this thing, if we drew our triangle again, that way and that way, again, this is going to be our rise. And this is going to be our run going down the bottom. If we want to figure out what these numbers were, we can count again. So 1, 2, 3, 4, 5, 6, 7. But I'm starting from the end point and I'm counting down 7. If I'm counting down 7, that means this is going to be negative 7 is what we're going to call it. It goes negative 7 down. And then it's going to be 1, 2, 3, 4 over. So then that'd be negative 7 over 4. So if we're doing A, B, that would be a rise of negative 7, a run of 4, and then our slope would be negative 7 over 4. And I'll let you do the last one, or the next one, EF there. But I just want to make sure we kind of get this one right. GF, it's kind of difficult to visualize sometimes. If I'm trying to figure out what my rise and run of this thing are, well, I have a run of 1, 2, 3, 4, 5, 6, 7. That's what my run is. But what's my rise? I don't have a rise, right? There's no rise. The rise is 0. So in that one, we'd say the rise is 0. The run is 7. So 0 divided by 7, well, 0 divided by anything is 0. So it has a slope of 0, which makes sense, right? This thing doesn't have a slope. It's not sloped at all. It's flat. All right. Moving on. Each line on the grid passes through at least 2 points with integer coordinates. So it just passes through 2 points. It doesn't. It's saying now that it's not that the endpoints are necessarily landing on an integer, but it does pass through 2 integer coordinates. So we're going to do the same thing. So calculate the slope of, let's say, line 4. What I can't do now, or what won't be easy to do, is if I took the endpoints of this line and drew a triangle like I did in the last one, I don't really have nice numbers to deal with. That should be a straight line. I don't know if I'm dealing with 1, 2, or what I have down for a slope there, or up and down, right? They're kind of in the middle of nowhere. So what's going to be a lot easier is if I use, because it does say it passes through at least like their integer numbers. So what I'm going to do is, it's saying this one is an integer number, right? It passes right through that point. Same with this one. So I'm going to use those. That's going to be a lot easier to use. So I'm going to use those, and I'm going to make a triangle out of this. Now I can say, well, I've got a rise of 4 and a run of 1. So my slope in this case is just going to be 4 over 1, or 4. So that's my slope, right? You can see that no matter where I check this out in the line, let's say I did know what these decimal numbers were and I made my triangle all the way to the end in there, I'd still have 4. It would still end up being 4. It'd be a bigger number for a rise and a bigger number for the run, but the ratio of that, the rise divided by the run, is always going to be the same. It's always going to be 4. So no matter what points I pick on this line, they're always going to end up being 4 for the rise divided by the run. So if you get that, that's great. All right, you guys do line 5 and line 6. Just remember line 5 here, though, it's running downwards, so you're going to have a negative slope. And we'd technically, you'd say that the where's our point going to be? Let's make, yeah, so that's a point, and that's a point, it looks like. They're running through, right? So let's make our triangle right there and there. Your rise, you'd call negative, so this would be -3. Yeah, so technically, but yeah. So I'll let you guys do that one. All right, so for this one, it's saying it passes through, our line passes through -5, -2, and has a slope of this. So right off the bat, what I'm going to just make sure you know is that the top number here, if this is our slope, the top number was our rise, right? Our bottom number was our run. So I'm going to, just knowing that, I'm also going to put this point on my plot, so -5 and -2, so that's right there. And then what I'm going to do is I'm going to use this rise run formula. So if I have a rise of 2, then I'm going to start from this point and go up 2. And then a run of 3, then I'll go over 3, so I'll make a point there. So now I know if I make a line that passes through both these 2 points, it's going to have the proper slope. And I don't have a straight edge. You should use a straight edge for this because it says to continue the line out like that in a straight line. And then it just wants to know, write the coordinates of 3 other points on the line segment which have integer coordinates. So really you're looking for places that it crosses pretty perfectly at on the 2 lines there, because that would be an integer coordinate, right? So look for a couple of those points. Mine might not be perfectly right because I didn't use a straight edge, but when you use a straight edge, look for a line. That might be one, I'm not too sure. Whoop. That's worse. Okay, so go ahead and do that. So I'll help you out with this one because the negative might kind of throw you off here too. So I'm going to draw my point first again here. So if I go -9, 6, so that's 5, -6, 7, 8, -9, and then up 1, 2, 3, 4, 5, 6. That's my point up in the corner there. And now it says it has a slope of -4, 3. So I know that right off the bat, this slope being a negative is going to go this way, right? That's a negative slope. That would be a positive slope. So what I'm going to do is go, since it's negative, that means I've got like -4 over 3 is another way of writing this. This would be the same thing to say -4 over 3. What that means, the negative sign, is I'm going to go down 4. So I'm going to go 1, 2, 3, 4, and then over to the right, 1, 2, 3. So we can do the same thing. So you're just going to connect those points. Use a straight edge again. Oop. And go all the way down. All right. So this one here, just a little bit of algebra. It's not too bad though. So we're going to use our slope formula. So slope is equal to 5 over 7. So it's say now I know that the slope of this thing is 5 over 7. And I want to know if they give you the run of 49, what the rise was. So what I'm going to do is say 5 over 7, because that's my slope, right, is equal to rise over run. But now I know what my run is. It's 49, so I'm just going to erase run and replace that with 49. And this is what it's really looking for, right? It's looking for my rise. And you guys, I know in elementary school, in grade 9, I think, too, your teachers have shown you something called fish. So you can say, if I want to figure out what the top is here, or what the rise was, I can go 49 times 5 divided by 7, and that gives you rise, right? You can fish or do that thing to figure that one out. So that's the other name for that is cross multiplying. But the other way, since we know how to do algebra now, what I'd like to rewrite this as 5 over 7 is equal to, and instead of rise, I'm going to write x, and then I'm going to write over 49. Algebraically, what we would do here is we want to get x on its own. So we'd say, okay, I want to get rid of this 49. So I'd multiply both sides of this equation by 49. The 49 on this side would cancel with that one. And what I'm left with is that x is equal to 49 times 5 divided by 7. So this is really what's happening, right? This whole fish cross multiplying thing, that's kind of a gimmick. But you can see we do the same thing. You go 49 times 5 divided by 7. And when we fish this thing, we go 49 times 5 divided by 7. So this is a gimmick. If you really need to use it, that's fine. This is what's happening. I would like you guys to do this one. It's more correct, I guess you could say. It gets at the point of why we're doing it. So yeah, go ahead and do B and C. It uses the same thing. And actually, I think I've said everything I want to say for this one. I want to let you guys go ahead and do the last 3 questions on your own there. Okay, so I'm going to end that video there. See you guys in the next one.